In section 6.4, we're going to talk about scatter plots and trend lines. Turn to page 399 in your text, and we're going to look at this gray box together. Essential understanding. You can determine whether two sets of numerical data are related by graphing them as ordered pairs. If two sets of data are related, you may be able to use a line to estimate or predict values. A scatterplot, vocab word, is a graph that relates two different sets of data by displaying them as ordered pairs. Most scatterplots are in the first quadrant of a coordinate plane because the data is usually positive numbers. You can use scatterplots to find trends in data. The scatterplots below show the three types of relationships that the two sets of data may have. Most likely you've done this before. You will notice that in the first one, the dots go uphill, therefore there's a positive correlation. The next one we have a negative correlation because the dots are going down. And then when they're scattered all over the place, we have no correlation. So in problem 1, we are making a scatter plot and describing its correlation. So on page 400, the Got It shows a scatter plot of the data in the table below. What type of relationship does this scatter plot show? So as you can see in your table, we have gasoline purchases, so we're going to put that as our title. So I've started the graph, and you'll notice that I put a title and I label both axes. So as a scatter plot, once again, you're going to have points that are just scattered. So by looking at this, I see my x values. My highest one is a 13, so I'm going to count by 2s. So I'm going to do 0, 2, 4, 6, 8, 10, 12, 14. My y values only go up to approximately 3.3, so I only need to number to 3. 1, 2, 3, and I'll just go to 4. So now you just plot the points. So the first one is I spent $10 and I bought 2.5 gallons of gas. So $10, 2.5 gallons. $11 for 2.8. $9 for 2 3/10 gallons. And I'm just going to continue this. And if you graph it, it looks roughly like this. You'll notice that a couple of the dots look like they're almost on top of each other. That's okay. So, what type of relationship does this show? Well, these go uphill. So it shows a positive correlation. Now part B says, consider the population of a city and the number of letters in the name of the city. Would you expect a positive correlation, a negative correlation, or no correlation between the two sets of data? Well, the length of the city's name and how many people live there obviously are going to show no correlation. So no correlation would be part B, but always make sure you have an explanation. The reason is because the length of the city's name and the population are not related to each other. At the bottom of page 401, you will see another gray box. It says when two sets of data have a positive or negative correlation, you can use a trend line to show the correlation more clearly. A trend line is a line on a scatter plot drawn near the points that shows a correlation. This sometimes is also called the line of best fit. You can use a trend line to estimate a value between the two known data points or values, or to predict a value outside the range of known data points. Interpolation is estimated value between the two known values, and extrapolation is predicting a value outside the range of known values. So problem 2 on page 402 says, make a scatter plot of the data below. Draw a trend line and write its equation. What is the approximate body length of a 7-month-old panda? So I'm going to let you draw this on your own. I'm going to pause my own video, and I'm just going to go ahead and draw it since we've already done this. So right now I have drawn a scatter plot of all of the relationships between the age in months and the body length in inches of the body length of a panda. So what we have to do now is we have to draw a trend line. This is sometimes called the line of best fit. So I'm just going to make a line through any points that I see here that kind of make a line. So I'm going to draw this. Now, this is going to be really important for you to understand that not everyone in class is going to have the same equation. It'll be similar, but everyone will not have the same equation because your line may go through other points. So what I'm going to do is I'm going to pick any 2 points that line goes through. So let me pick the value. And it looks like I drew it through 929. That's this one right here. And let's do 4 right here. 416.7. So remember once again how you determine from your graph that you've drawn, you have to write an equation for that line. And we've done this before a couple chapters ago. So we first have to find the slope. So let's find the slope. M equals, we'll take 29 minus 16.7 and 9 minus 4. That's going to give us 12 3/10 divided by 5, which gives us a slope of approximately 2.46. So now I have a slope and a point. Now you can pick either point, and now you have to use point slope form. Point slope form is y minus y1, so that'd be y minus 29 equals 2.46 times x minus x1, which is x minus 9. So I distribute 2.46x minus 2.46 times 9, 22.14. I then add 29. Y equals 2 4600ths, or 2.46x. And 29 minus 22.14 gives me 6.86. So there is a trend line that I've drawn in green with its equation. The equation is y equals 2.46x plus 6.86. The last part then says what is the approximate body length of a 7-month-old panda. So you take the 7, and I'm going to do it down here. Y equals 2.46 times 7 plus 6.86. All you do is use your equation to figure that out. So 2.46 times 7 plus 6.86. The approximate body weight is going to be, or body length, 24 inches, or you could even say 24.1 inches if you rounded to the nearest tenth. So my answer will be approximately 24 1/10 inches. So what we did is we found data based on the points between what we had. So we did interpolation. Now, part B asks, do you think you can use your model to extrapolate the body length of a 3-year-old panda? Part B, no, you can't, because this only represents age in months and body lengths in inches of a panda, and an adult panda and a baby panda are going to grow at different rates. So just like an adult human and a baby human, an adult human is not going to grow lengthwise at the same rate as a baby would or a child. So on B, you'd say no, because an adult panda does not grow at the same rate as a young or a child panda. On top of page 404, there is another gray box that leads into what we're going to do next. The trend line that shows the relationship between two sets of data points most accurately is called the line of best fit. A graphing calculator computes the equation of the line of best fit using a method called linear regression. The graphing calculator also gives you the correlation coefficient, which is R, a number that goes from -1 to 1. That tells you how closely the equation models the data. The nearer r is to 1 or -1, the more closely the data cluster around the line of best fit. If r is near 1, the data lie close to the line of best fit with a positive slope. If r is near -1, the data lie close to the line of best fit with a negative slope. If you get r is -1, your line goes downhill. If it's r of 0, there's no correlation, and closer to 1, it's a strong positive correlation. Now, I can't teach this to you without graphing calculators, so unless everyone would have one at home, which I know not everyone does, we can't do this. So we're going to actually finish these sections tomorrow in class using the graphing calculators that we have that I will pass out, and we'll do this together. So we'll finish the notes tomorrow in class.